Nintendo Switch. Let me show you what's going on with the port. I'm a little suspicious about it. I think you can see that. You see that one pin there kind of sticking up? It tells me the port has taken a little bit of wear and tear. I think it might still be okay to try power, but if we get something large, we're going to pull that thing real quick. Let's just see what it's doing here. Oh, that's straight 0. Wow. Okay. And that's straight 0 on both sides. Okay, well, we're getting exactly 0 amps. Okay, so that could be several things in my experience. That could be the port itself. That could be the port fuse. That could be M92T36. Though it's more common for you to be drawing like a 0.8 or something like that, or like a point. Recent video, the recent one I did was like a 0.14. Could be, I guess it could be one of the far left filter. If you're looking at Pi 3 USB upside down, that far left filter, sometimes it's the smallest filter, could cause that as well. So that's the things I would generally look for if I'm getting like a 0 amp draw. But we won't know until we get it apart and enough to do some testing and go from there. This video is brought to you by PCB Way. PCB Way is celebrating its 8th anniversary with a promotion. This promotion includes free coupons, PCB and orders at up to 50% off, up to 50% off 3D printing and CNC machining, special sales, and lucky draw. Check out my affiliate link in the description for a $5 coupon off your first order. Now back to the repair. Okay, we have disassembled enough to do some initial testing here, and let's see if we can figure out what is going on here and why we're only pulling 0 amps. Let's switch it to microscope. And we'll start where we normally start, and that is around the M92T36. Let's find ourselves a good ground. And we'll start with this capacitor, which is tied to Pi 3 USB on the back. And it appears to be okay. The line we don't want shorted to have a pathway to ground is the line going to the chip. This one appears to be shorted, so that's M92T36. This is the second one in 2 days that I've had that capacitor shorted, and I've never really had that capacitor shorted before, so interesting. It's just like that capacitor, huh? Even more interesting. Oh, there we go. That one's shorted as well. Okay, let's move up the line. See what else we got going on here. Check our MOSFET. Ooh, we have a short on the MOSFET line. Interesting. One of these MOSFETs might be bad. So that'll be interesting. I want to see if when we remove the M92T36 if this short gets relieved. Otherwise we're going to have a problem on one of these MOSFETs. Interesting. We're going to go ahead and remove the chip because we have chips, and that's probably the simpler solution right now. So we're going to remove these chips first, the chip first, and if we continue to have a short, we will look at the MOSFETs. Not a big deal to replace the M92T36. Okay. Let's check our invincible fuse and see if it's still being invincible. That is a big no. The fuse is blown as well. Very interesting. Okay, let's check our test pads. Okay, no shorts on the test pads. Alright, let's check our coil, make sure it's not shorted to ground. Ooh, our coil is shorted to ground. Wow. Usually if that coil is shorted to ground, we have a problem over here on the max. So I am curious now. That is not a good sign, kids. Now we are shorted all over the place over here. And it doesn't look like it's due to liquid. So this could be a serious issue. Yep, shorted as expected. This was not shorted. I was accidentally hitting that. But this is. Wow, we are shorted all over the place. Okay. Lots of problems so far. Yeah. Okay. We will have to disassemble this entirely. We're not going to do much else besides that. And look at the other side of the board, and then we're going to see if we can, you know, piece at a time, solve or figure out why all these things are shorting. And hopefully this will be fixable, but I have to say my optimism has dropped considerably at this point. So let's disassemble and go from there. Okay, let's have a look at the other side of the board here. You will see things as I see them. We'll grab our meter and start doing some testing over here. If the port were bad, I would expect to see shorts on these lines. So continuity straight through, not side to side. Okay, we do not appear to have a problem on Pi 3. Let's take another look around because, man, there's a lot of things shorting on this thing. I just want to see if there's anything obvious going on this board. Let's start with M92T36. The fuse is really going to be the last of my concerns. I want to relieve the shorts first, and I'm not going to worry about putting new chips on until we have dealt with the shorting problem, because we may just be wasting our time. That max IC area being all shorted has me legitimately concerned. While I am setting up my equipment, I will throw up our expected temperatures for whatever this job ends up being. As always, these temperatures are subject to change. If the job changes, I may actually use the 20% at some point in this job. Probably like for the fuse. If we get to that point, the fuse will be the last thing I worry about. As always, these temperatures are brought to you by the Amazon associate links you can find in the description. If you click on any of those links and buy any of that equipment or buy anything during this session, a small portion of that purchase will go to supporting the channel and be greatly appreciated. Will not cost you an extra dime. Alright, switch you back to microscope, and we will use some NC559 ASMTF flux to remove this IC, and then we will test and see if our short is relieved. If it is not relieved, we will move to the MOSFETs and remove one and test, and remove the other and test, and we'll just have to systematically go from there. And then we'll have to worry about the short around BQ. Alright, let's check that check that capacitor again. Okay, we are not shorting. Let's check our MOSFET area again. Okay, we're not shorted anymore. Interesting. Make sure that didn't affect anything here. I think we're still going to be shorted. Yeah, we're still shorted. Alright, that's not going to be BQ in my experience. That's going to be our max IC area. Okay, those should not be shorted like that. Alright, so I think we're going to have to remove that max IC and see if those shorts get relieved. And we may remove the BQ, but I don't think, again, I don't believe the BQ is going to be the issue here. So we'll start with the max and really hope that that short goes away. Not exactly how I wanted to pull it, but it worked. Test again. That short is still there. Alright, we're going to try one more thing and pull the BQ, but I'm afraid this guy's going to be donezo. Well, our short is relieved. Okay, interesting. Okay, I guess we'll grab another BQ, put it on, test, and make sure we do not have a short reappear. Make sure we have not reestablished a connection with the short. Alright, no more short. Okay. Let's put our N92T36 back on. Grab the chip. Thank you. Clean up these blobs. And then we'll test. See if our short returns. We hope not. Alright, still no shorts. We'll check our MOSFET area again. Still no short there. We'll do the fuse next. We'll just try and hand remove this one with a blob of solder. Go. Grab our new one. Now we'll drop down to 20%. So our new fuse in. Or at least get its attack down, and then we'll bring in some airflow. bring up the airflow just to get it fully flowed in. Good enough. Test to make sure it survived. It did. Very good. Alright, deal with our max IC area. First thing we need to do is prep. Mix some leaded solder in there. A high amount of precision, preferably. So actually I have these ICs pre-balled already, so I don't really need to re-ball this one. I will save this one so I can re-ball it later. Second, see if we got it tacked down. Okay, we did. Now we add some flux. Okay, let it float. Okay, we've not got any shorts where we shouldn't have shorts. There. Make sure we're not short over here. Okay. Ultrasonic toothbrush is very good for cleaning around BGAs. Don't use it for everything. I don't use it as much as I thought it would, but it does come in handy. Okay, I feel like that'll be thorough enough for our needs at this point. We're going to do a quick power test. Be watching the meter on the left, and let's just see what happens. Do we get anything resembling normal? We're still getting 0. At this point, I am thinking we need to change this port. Just make sure we didn't just pop our fuse. Nope, our fuse is still good. So we shouldn't still be getting 0 there. So we are going to have to change the port as well. I'm just using this bevel tip because I changed it over to do the wicking, and I don't feel like changing it back at the moment. Plus it's kind of handy. It actually sucks up the low melt into the bevel, little hole at the end of the bevel. So I accidentally decided I like this one better for this job. Move the port. I'll hop right on the wicking because we don't have to do any testing. Back to our benches. We want nice puffy pillows. Okay, again, using our normal method. We're just bringing up the temperature of the board enough to wet the solder. Everybody's wetting. Okay, hold it down. And wait until we see the pads that we can see dry. That's pretty much want them to dry all the way across. And hold down for a few seconds longer, make sure the hidden pad's dry. Alright, now we'll do a little nudge test. That feels solid. And apologies, most of that was on the wrong screen. They all seem to do a million ports though, so. Real quick, I'm going to clean this port off screen because I want to use my air compressor and stuff, and then we'll come back for another test. Okay, let's cross our fingers and hope our work is going to pay off here. Channel is on. Let's see if we get anything resembling normal behavior. Oh, come on. And that is starting to not make a lot of sense. We should be getting something now. That don't make sense. Get a bridge here. Alright, I'm bridged. Dang it. How did I not see that? I don't even know how that happened. Yeah, I'm not really sure what the heck happened there, but the reason why I don't usually wick or resolder in this area is because these get bridged very easily, and somehow they got bridged even without me doing that, so very strange. See if we get anything that resembles normal behavior. Or anything would be good. Okay, that resembles normal behavior. Alright, and that resembles normal behavior. We'll try activating with our OEM on the battery squid. And that looks like normal behavior. Very good. Okay, now that we have finally gotten some behavior out of this thing, we will put it back in the housing enough to do some testing, and then some initial testing just to make sure it boots up, and then we'll charge it on its own battery for a while and test from there. Okay, let's see if our labor has fruit. We're using a charged battery. Okay, full battery symbol. And we are booted up. Uh-oh, we're getting no touch though. Better. Let's try again. 0.47, full battery symbol, should get a reset. Fast charging, that's good. And now we got touch. Excellent. Okay, let's try the other side. Make sure we're getting charging on both sides. And fast charging on both sides. Excellent. Okay, we will reassemble most of the way. I don't want to reassemble entirely until we can get a dock test done. In order to do that, I need to charge their battery for a while because I can't really do it with a battery hanging out the back like with my test battery. So we'll charge their battery a while, and then we'll do a dock test, and then we'll proceed with the rest of the testing if that checks out. Okay, and as you can see, it is docking. Excellent. That's excellent news. That means we don't have to go back and deal with that. That usually requires a complete disassembly, so everything else is kind of workable. So we'll go from there. We have a few more tests to perform. Okay, and as you can see on the USB charger, we're pulling 0.91 on 15 volts. That's good. We're going to plug in their Joy-Cons and make sure they're being recognized and being picked up and charging. Okay, both sides are good, and we're charging, but they do not have enough charge to test the Bluetooth at the moment. CAN cartridge reader is working. See if we're picking up our networks, and we are. Excellent. We might only get a second of Bluetooth here, but we're getting it. Good. Excellent. It's working. All right. That's really it for this repair. We finally solved this thing. It was quite an adventure. So in summary, we had a Nintendo Switch pulling 0.0 amps. We made some assumptions of possible port, fuse, M92236. We opened up the system, and we had all sorts of things going on. As expected, we had shorts around the M92236, kind of in an unusual place. Then we moved up the line, and we had shorts around the MOSFETs, which was very unusual. We don't usually get that. And then we moved up the line, we had a blown fuse. And then we moved over to the BQ24193. We had shorts around the BQ24193 in an area that's usually indicative of the Max IC being an issue. So we moved over to the Max IC issue, and we did have shorts there, but it actually turned out that the shorts were not caused by the Max IC. So in the future, I may just go ahead and attempt the BQ24193 before assuming the Max IC, because the Max IC is just more of a pain in the butt because it's a BGA and it's a really high temperature area to rework. So I think next time we just assume BQ, or at least eliminate the BQ first, because the BQ is much easier to rework. So yeah, we kind of learned a lesson there. So we just systematically, first we replaced the M92236, make sure those shorts were relieved. They were, so that was good. And then we went up the line and we pulled the backs. Unfortunately, the shorts still remained. Then we pulled the BQ24193. That relieved the shorts in the max area and the BQ24193 area. Then we replaced the fuse. We came back and we were still getting 0 amps. So I made the call to replace the port. The port was in pretty rough shape anyway, so it was probably a good idea to do. It had that one lifted pin and stuff like that, so it was not a bad thing to do as far as the repair went. But we were still getting 0.0 amps with the new port. Went and investigated further, and there were some bridged caps. I have no idea how those caps got bridged. I'll have to go back and look over the footage. I probably have by the time you see this, but yeah, I had no idea how those caps got bridged around M92236, but we cleared those bridges and we tested again, and we got normal behavior. We got normal behavior on the battery squid, so we put it back together and everything's checking out. Dock is checking out, everything else is checking out, so all good. As you can see, we're fast charging, so that's excellent. Anyway, that's all I have for you in this repair. I appreciate the channel supports. If you have any questions, please leave them in the description below. I'll be happy to answer them or direct you somewhere that I can answer them. And that's all I have to ask you. Appreciate you watching. See you next time.